Hey guys, thanks for joining this tutorial. Today we're going to be building a lottery smart contract in Solidity step by step from scratch. We'll start by reviewing some basic architecture and then use the Remix editor to develop, deploy, and test our code. This contract will be a bit more complex than the ones that we've done before, so if you feel like reviewing some of the fundamentals, check out our Smart Contracts 101 and Vending Machine tutorials first. Otherwise, feel free to jump straight into this one. In this tutorial, we're going to get some more practice with sending and receiving funds in Solidity, as well as looking at a couple of different ways to generate randomness in our smart contracts. So if that sounds interesting, stick around and let's do it. Before we start coding, let's establish a basic architecture for our smart contract. So the principle behind a lottery is pretty straightforward. Players enter the lottery by contributing a certain amount of money. That money constitutes the lottery pot. Then at some point, a winner is chosen at random, and they receive all the funds from the pot. Okay, so next let's think about what kind of objects and functions will we need in our program in order to facilitate that logic. Let's start with global variables. So the first one's a given. We'll need an owner, that is the person who, or the address who deployed the contract in order to execute some administrative functions. And we'll talk more about that in a little bit. Secondly, we'll need a list of all the players in the lottery. Now we have a couple of choices when it comes to Solidity. We have a mapping, which is basically an object of key value pairs. And we have an array, which is essentially a list of values. The only thing we'll really need here is a list of player addresses, so I think the array might be our best bet. Next, let's move on to functions. First of all, we'll need a way for people to enter the lottery, so we'll use an enter lottery function. And this function will have to receive ether in order for them to enter the lottery. Second, we'll need a way to generate a winner from our program. So we'll have some sort of pick winner function that will use a random number to choose at random one of the players who's entered the lottery, and then forward all the funds to them. Next, we may have some other more optional sort of utility functions. We might want to have something to get the pot balance. This will be helpful for testing. We might want something to quickly give us a list of all the players in the lottery. Is there anything else you could think of that we might need in our smart contract? All right, I think we're ready to jump into some coding, so I'm going to go ahead and open my browser, and I'm going to search for the Remix editor. All right, so that URL is remix.ethereum.org. Now, we've used the Remix editor in past videos, and it's just a really good way to start coding and be able to deploy and test our code fairly quickly. So if it's the first time you're here, you'll see a default homepage and maybe some pop-ups. Go ahead and you can dismiss those. Now let's expand our contracts folder, and we'll use one of these sample contracts to basically start building our lottery smart contract. So let's go ahead and rename the first one, and I'm going to call it, lottery. Okay, now let's go ahead and select all the sample code there and go ahead and delete that, so we're starting fresh. Okay, so the first thing I'm going to do, and this is the way I start every smart contract, I'm going to go ahead and specify the license identifier. So that's SPDX, all caps, dash license dash identifier, colon, and then I'm just going to go ahead and use the MIT license, which is what I usually do here. All right, next let's set our version of Solidity. So I'm going to type pragma Solidity, and 0.8.11 is the most recent version at the time of this video. Let's go ahead and save that. Now we already see a prompt over to the side that we have a mismatch with our compiler, our Remix compiler, and the version that we've specified in our code. So go ahead and make sure that we have 0.8.11 selected, and that error should go away once we save again. All right, so let's define our lottery contract. Keyword contract, and then lottery in capital with capital L, and give it some curly braces. All right, so the first thing we want to do is to set up some instance variables, some state variables. And if you remember back to our architectural discussion, we said the first thing we wanted was an owner variable. Now the owner is basically going to be the address of the person who deployed the contract. So I'll give it a type of address. We'll say public and owner. Okay. Now the next thing we said we wanted was a list of the players, and we decided to use an array. So remember in Solidity that to create a new array, you first have to specify the type of the objects in the array. So I'll say address. No space between address and the square brackets. We'll make this public, and then we'll call it players. Now, there's one more thing we need to add here, and that is something called a payable modifier. Now, this is fairly new, I believe, since Solidity version 8, and we use the payable modifier for any addresses or functions that can receive Ether or receive some sort of payment. So we'll want to make sure that we have the type address, the modifier payable, then our square brackets, public and players. Great. Okay, let's define our constructor next. So we'll use the constructor keyword, and we'll give it some we'll give it some parentheses first. Now our constructor doesn't need to take any arguments, so we don't need to code anything in here. Let's go ahead and set our owner address. Now this is a pattern that you'll see pretty often, and we've done it in, I think we did this in our vending machine contract, maybe some of our other ones as well. The way we can get the address of the person who deployed the contract is with the message global variable .sender. All right, so inside of our constructor, we're setting the address of the person who deployed the contract to our owner state variable. All right, great. So far, so good. All right, let's start with our enter function. Now we'll define a new function in Solidity with the function keyword, followed by the function name. Okay, we don't need any arguments. We'll make this a public function. Now again, we'll need the modifier payable, because remember, when somebody enters our lottery, they need to send in some sort of Ether, some sort of value. That's why we need to make this a payable. Okay, and we don't need a return type because we're not going to be returning anything from this function. Okay, so in order to enter somebody into the lottery, the only thing we have to do is add their address to the players array. All right, now if you've used JavaScript, the syntax is going to look very familiar here. So we'll say players, the name of the array, dot push, and that's a way to add an item to the array. We'll say message dot sender, because in this context, message dot sender, it's a little bit different from what we had in our constructor. In this context, in the context of a function invocation, the sender is literally the address that invoked this function. Okay, so this will give us the address of the person who wants to join the lottery. Okay. Now, there's one more thing we need to do here. So if we just take message.sender, that's going to give us an address type, but not necessarily an address payable type. So we need to cast this to payable. And we could do it like this with the payable keyword and some parentheses. So now we're saying, okay, take this address of the person who's invoking this function, convert it to a payable address, and then go ahead and add it to our players array, which is an array of payable addresses. So we have to have that consistency here in order for this to work. Let's just comment this to make sure it's clear what this is. I'll say address of player entering lottery. All right. Now, there's still one piece missing here because we said that a requirement for joining the lottery is that you have to send in some amount of Ether, some kind of money, right? So what we can do, we can use a require statement to enforce that restriction. So I'll say require. Again, I'll use this global message variable. Now, we use it here to access .sender. We can also we can also use message to access the value being sent in on this transaction. So in other words, the value of the ether being sent in with the transaction. So let's say the value has to be greater than, let's say 0.01 ether. Okay. Now the reason I'm using a rather low value here is because we're going to need to eventually test this with test ether. So, you know, I just want to make sure that we have enough to test this. Right now, the amount doesn't really matter. You could change this before you deployed it to production to, you know, whatever you wanted. So another note here, usually message value and in general values when you're dealing with transactions in Solidity are typically entered in way, which is a subdivision of ether. But you know, you're dealing with a lot of zeros basically when you write values in way. So I'm basically casting this to ether, or I'm not casting, so to speak, but I'm just specifying that this is going to be an ether. If I left off this, it would default to way. Okay, so this is just a sort of a convenience utility to make this a bit more readable. All right, so I think our enter function is done. Everything looks good so far. All right, so let's take a look back at our architecture diagram. Now, the next function that we wanted to write was our pick winner function. So this should basically look at the player's array and at random, pick one of the entrants to be the winner. Now, in order to do this, we need to get a random number. Now, this brings up a pretty interesting topic because there's no native random number generator in Solidity. And even more so than that, the blockchain itself is a deterministic state machine, which means if you know the state of the system at any given point of time, any future states are predictable, which means there's no randomness in the blockchain. The other thing is that the blockchain is completely transparent. So anyone can look at any smart contract, view any data at all at any point in time. So the best we can do working in Solidity in the Ethereum blockchain is come up with a pseudo-random number. So a pseudo-random number is not something that's truly random. It's something that, you know, given enough data and enough number crunching, you theoretically could figure out what that quote-unquote random number is. Okay, so it's not 100% safe, basically, is the takeaway. So for this video, we are going to use a pseudo-random number using a hashing algorithm in Solidity. And then video part 2, we're actually going to refactor that to look at some different ways to generate a truly random number by using off-chain processing. Okay, so for now, we'll go with the pseudo-random number. That should definitely be good enough for testing purposes and to get a working functioning lottery contract up and running. All right, so I'm going to go back over to my Remix editor, and before we code our pick winner function, we're going to code our get random number function. All right, so function keyword, and let's say get random number. Okay, no arguments. Let's just make this one public for now. We'll say view because it's not modifying any blockchain data, it's just reading it. And let's say returns, and our random number is going to be uint, unsigned integer. Okay, give it some curly braces. All right. So as I said before, we're going to use a hashing algorithm, which is native to Solidity, in order to hash some data together to get a pseudo-random number that's going to be good enough for us to use for now. So, all right, so whatever we do, we're going to need to cast it back to an unsigned integer. All right, so just do uint parentheses, and then inside that, we're going to use the Kesak 256 hashing algorithm. Now, I may be pronouncing that wrong. There's a pretty good chance. Let me know in the comments if you know the correct way to say it. Okay, and what we're going to do is we're going to hash together our owner address as well as the current time, which we can approximate by using the block global variable with timestamp. So that's going to give us the timestamp of the current block. All right. Now, one thing we need to do here, because this hashing algorithm basically takes just one parameter, so we need to concatenate these two together, owner and timestamp, before we hash it. All right, so by doing that, we can use another global variable, abi.encode packed. And I believe we saw this before in the Solidity 101 tutorial. The reason we have to use this helper function here is that there's no native way in Solidity to easily concatenate two strings like there is in JavaScript. All right, so once again, we're concatenating the owner address with the block timestamp. We're passing that to the hash 256 algorithm, and we're converting the result to an unsigned integer and then returning it from this function. All right, let's move on to our pick winner function. So I'm going to say function pick winner, no arguments needed. Let's make this one public, and we don't need to return anything from this function, so give it some curly braces. Now, what we want to do inside our pick winner function is we want to get a random number by calling our getRandomNumber function, and then use that random number in a way to look into our players array and choose at random one of the indices from this array. All right, so our ultimate result here is to get an index from that array. So let's say uint index equals, and then we'll call our getRandomNumber function. Now, the way we can use our random number to randomly choose an index between 0 and array length -1 is to use the modulo function like this. And we'll say players.length. So when we get a random number and use the modulo operator, which gives us the remainder of a division operation, and use players.length, that is guaranteed to give us a random integer between 0 and the length of the array -1. Okay, so in other words, it is a way to, at random, choose one of the indices of that array. All right, now once that's been chosen, we simply need to transfer the funds to that address. So we'll say players of the index of the winner transfer, and we'll say address this dot balance. All right, so let's break that down a little bit. So we're saying basically take the winner, which is the index here, from our players array and transfer to that account, because this is an address, right, the balance of the current smart contract. So address this gives us the current, a reference to the current smart contract. Dot balance gives us a reference to the balance of that contract, which will in turn be all of the money, the value that's been sent in by the players. Okay. One final thing we want to do, so after the winner has been paid, we want to reset that array for the next round, right? So reset, let's see. I'll say reset the state of the contract. And so we'll basically create a new players array to overwrite the old one. I'll say new address payable and 0. So this is a way to create a new array with length 0. All right, so now we're ready for our next round of play. All right, so far so good. All right, so before we move on from the pick winner function, I forgot one thing, and that is that we want to restrict the use of this function to the owner of the contract. So how would we do that? Well, how have we basically restricted certain functionality in the past? We've used the require statement. So again, we could do something like this. We could say require message.sender equals owner, and that would work. Now, what if we had several functions throughout our smart contract that had the same sort of restriction? Because this is a pretty common one to have, right? So in that case, we could create what's called a custom modifier. So it's just a way to, it's just something that promotes code reuse. So instead of having this hard-coded in one function, we could create a reusable modifier. And here's what that would look like. So we'd say keyword modifier, and then let's give it a name. I'll say only owner. Okay. Now inside here, we can copy and paste our require statement. All right. And then below that, we need a special piece of code, which is simply an underscore with a semicolon. And that's basically saying whatever other code is in the function that this modifier is applied to, have that run after the require statement. So basically, in this case, that would be referencing all of the other code of our pick-winner function body. All right, so now all we have to do is take the name of our modifier and place it right here in our pick-winner function. All right, guys, so we are just about ready to take our code for a test run. But before we do that, let's take one quick look back at our architectural diagram and look at some of the optional or utility functions that we said might be useful. So the first one was get pot balance, and then we said get players might be useful to have. So let's do a quick implementation of those two, starting with get pot balance. All right, so I'm going to go back over to my Remix editor, and I don't know, for some reason I feel like putting this one a little bit more towards the top, so I'm going to go right under my constructor function, and let's create a get balance function. So again, function keyword, get balance, no arguments. We'll make this one public because anyone should be able to view the lottery balance. We'll say view because we're only reading but not modifying blockchain data. And we'll give it a return type, returns unsigned integer. And let's go ahead and give them some curly braces there. All right, so this one's fairly straightforward. Return address this dot balance. And so this is a pattern that we've definitely seen before. Address this being our common reference to our smart contract, and then accessing the balance property from there. All right, what was the other one? Get players. So I'm going to say function get players, and again, no arguments. And again, we'll say public view returns. Now, we're going to return here, I think what we're going to do is return our address payable array. So let's say address payable, square brackets, and then we're going to give it a memory storage type. So again, memory indicates that this is just stored in temporary in-system memory only for the duration of the function lifecycle. All right, and we'll say return players, again referencing our address payable players array. Now these two, you don't have to add these. It's optional. It's just sort of nice to have. I think it'll be helpful during testing. All right. So let's go ahead and start to test our code. So go ahead and click on the compile button. And if you don't see it here, it should be on the second tab from the top. Oh, and looks like we may have some errors. Let's see what we've done here. Expected semicolon, but got... Can you guys see where my mistake is? It's either here or on one of the lines previous to that. Modifier. Ah, there it is. Spelling error. All right, at least that's an easy fix. So hopefully you guys didn't copy my poor spelling there, and you're probably not looking at the same error as I am. All right, so now we're able to compile our function, and let's go down to the next tab here where you have the little Ethereum icon, and let's deploy our contract. So we can deploy this to our virtual blockchain, so make sure you have the first item here, JavaScript VM London, selected. Notice that we've got our accounts all loaded up with 100 Ether, and we are ready to go. So make sure your lottery contract is selected here, and go ahead and deploy that bad boy. All right, looks like we have a successful deployment. go ahead and expand the contract details down here. And let's just sort of play around with this and make sure everything's kind of working. So let's start by checking our owner. Okay, and let's make sure that matches up with the address of the deployer, which looks like it does. Let's get balance. This should be 0, right, since we're just starting off. Great. Get players should be an empty array. We can test our get random number because that's an isolated function. There we go, a nice big random number. And yeah, I think that's good. So what we can do, let's simulate a little lottery here, and we'll start by entering a few people into our lottery. So I'm going to choose the second account down from the owner. And now what we're going to want to do is send in, we have a minimum of 0.01 ether. So let's figure out how many Wei that is. So I'm going to just Google for Wei to ether. And here we go, Ethereum unit converter. So I'll say 0.01, and that's this big number here. So you can see why I mentioned earlier that it's easier sometimes to specify ether in code. All right. So I'm going to copy that number. I'm going to go back here, and in our value field, I'm going to go ahead and paste that. Then I'm going to scroll down and hit enter. Oops, I saw a failure there. Let's see what's going on. Transact to lottery, enter, revert. So the transaction was reverted. I think this is it here. You sent a value. The value you send should be less than your current balance. I think we didn't account for gas fees. So I'll tell you what, let's try this again. Let's just add a bit more to this. So let's go to the very beginning. Let's do 1, 1. So change that second 0 to a 1. And let's try it again just to make sure that we've got enough. And there we go, successful that time. All right, I should have copied that to my clipboard, but let's do a couple of other accounts. So I'll do the third one here. Again, I'll paste in that Wei value. Modify it. This time I'm going to copy this. Oh, you know what? It's going to be easier to copy it from here for next time. Okay. All right, let's enter this account. Great. Let's do a few more. We'll do number 4. Enter. Let's do one more. Oops. Paste our value there and enter. All right, so we should have about 4 players at this point. Let's check. Let's get our players. There, does that look like about 4 addresses? I think it does. Now our balance should be something like 440000 Wei. Okay, that looks just about right. All right, so at this point, let's go ahead and pick a winner. Now, this is going to happen pretty fast, so let's take a look at our accounts and just notice the balance of everybody. They've all got 99.98, 99.9889 with a bunch of 9s. All right, so after we click on Pick Winner, one of these balances should be incremented, and that should be the winner of our lottery. All right, so let's see if that works. Now, very important, make sure that we're on the first address here, because remember, only the owner can actually invoke the Pick Winner function. All right, so let's go back down to Pick Winner. All right, looks like that was successful. So a couple of things we can do. We can check our balance. It should be back down to 0. Great. And our players should be empty again because we reset that in our Pick Winner function. So far, so good. Let's check the balances and yep, so it looks like this contract right here, or sorry, this address, the 4th one, was the winner because they're the only address that's up above 100. All right, so everything looks like it's working just fine. So far, so good. And yep, that's great. So let's look at what else we can do to sort of improve our contract from here. All right, so there's just one more improvement that I think I want to add to this contract for this video. Once we chose the winner, we had to sort of look at the accounts and manually figure out which one had been incremented to determine the winner. So I think it'd be nice if we just had some properties in the lottery contract to sort of keep track of the lotteries and the winner for each lottery as they're played. So what we can do, let's go up to our state variables and let's create a new variable for a lottery ID. So we'll say uint public, let's say lottery ID. All right. And then in the constructor, we can set the ID for our very first game. So we'll say lottery ID equals 1. All right. So now in our pick winner function, we'll want to increment this every time that a winner is chosen and we restart the game. So let's go ahead, let's go below our transfer function. Now, this kind of brings up a good point, which I think I'll cover in other videos in more depth, but just from a sort of smart contract security standpoint, there's something called the re-entry attack, and basically another contract is able to recursively call transfer and drain the smart contract of all of its funds. And the best way to protect it against this sort of attack vector is to, whenever you have any state that needs to be updated, first do your transfer and then update state after that. So that's, even though this may not exactly be one of those use cases, it's just good practice to get into that habit, because you don't always know when you are in sort of the risk zone for something like that happening. All right, so we'll increment our lottery ID right before we reset the players array. And this is all happening after we transfer the funds. All right, so we've got a lottery ID. You know, I think it might also be a good idea to keep track of who won each lottery, right? So we have a lottery ID, and then we would have an address representing the winner. So what would be the best Solidity data structure to handle a key value pair like that? We'll say we have an address that's keyed by the lottery ID. Well, if you guessed mapping, I totally agree with you. So for our mapping, and just to refresh your memory, in case you guys are seeing this for the first time, a mapping is basically, you could think of it as sort of a JavaScript object with key value pairs, but where all of the keys and all of the values have to be of the same type. So the way we set that up is with the mapping keyword, and then we specify the type, uint, the type of our key, and then we use sort of a fat arrow, like from JavaScript, fat arrow, and the type of our value. So we're going to say address payable, because these are payable addresses. And then after that, we can set up our access modifier. We'll say public. And then finally, we'll give it a name. And let's call this lottery history. Okay, so we've got that mapping set up. Now we want to update this mapping every time we choose a winner. So let's go back down to our pick winner function. Let's go right underneath our lottery ID, and all right, so we'll reference the name of the mapping, which is lottery history, and then we'll say lottery ID for the key, and then we'll set that to the address of the winner. So we'll say the players array of index, where index is the winner, as chosen by our random number generator, etc. All right, does that make sense? So we'll increment our history, we'll increment our ID, and then we go on to increment, to update the rest of the state, which is just the players array. All right, I think that's looking good. So this way we've got a nice history of all of our lottery games, and we can always go back and see who won any given lottery. All right, so let's just try to compile this. Good. All right, let's do another deployment and just see if we can sort of access these new properties. So everything, leave everything the same here, JavaScript VM, and let's go ahead and I like to delete my previous contract or my previous deployments first, then I'll deploy a new one. There we go. All right, let's click on lottery history and see what it gives us. I think we have a type mismatch somewhere. Lottery history. All right, I'll tell you what, let's check our lottery ID and then we'll figure out how to deal with the mapping. So great, we're at 1 here. I'll tell you what, let's just run a quick lottery and just make sure that increments. So again, I'll grab my value here and I'll choose the second account. We'll just do a quick test here. So I'll enter in 1. Oops. Okay, we'll enter this account. And let's do one more. And enter. All right, so let's quickly pick a winner. So I'll go back and choose my initial account, the owner account. And let's do pick winner. Okay. Now let's take a look at our lottery ID. At this point, we would expect it to be 2, correct? Cool, so that part works. Let's try our history again. Okay, and we're getting an error here, so I think what we need to do is implement a function to give us, you know, I think it's not able to display a big number type, which is what this is returning. So I think we need to create a utility function to look at that history keyed by lottery ID. So I'll tell you what, let's just do that real quick. So let's say get winner by lottery, okay? All right, so the argument's gonna be a uint. And this, let's see, we'll call it lottery ID. We'll make it public, we'll make it view, right? Because we're reading data from the blockchain, but not modifying. It's gonna have a return value, which is gonna be an address payable. Does that look right to you guys? I think that's correct. So return, let's see, returning a uint, so we need to reference our lottery history mapping by the argument, which is lottery ID. All right, I just want to take a quick look, make sure this looks right. Get winner by lottery. We pass in a uint, lottery ID, public view returns an address, because that's what the value is for this mapping. Return lottery history of lottery ID. All right, let's go ahead and compile this and test it out. So I'm going to delete this deployed contract. Let's first of all make sure it compiles. Oh, and there looks like there is some kind of warning. This declaration shadows an existing declaration. So it doesn't like lottery ID for some reason. I think it's just a naming thing. So yeah, let's just say ID. Normally I like to be a little more specific. Let's just see at least if it complains about this or not. I don't like using ID as a variable name because that could mean so many things, but I could call it lottery. Do I have a lottery variable anywhere? Yeah, let's see if that works. At least that's a bit more descriptive. I hate to use just ID. Let's compile that. I think it's auto-compiling, by the way. I keep hitting the button, but just force of habit. So, okay, let's go back down here and let's redeploy. Great. All right, I'm going to grab my value again here. let's go ahead. Well, I guess we can test this right away, right? Because we can, let's see if it gives us anything for the index of 1. 0 address, right? Because nobody's 1. So that looks good so far. That looks promising. Okay, let's do another very quick lottery test. And then we are almost done here, guys. So I'm just going to take, I'm going to use a new address that hasn't been used before so we can clearly see the values and things like that. Okay, enter. Up. This transaction has been reverted to the initial state. Something it doesn't like about the value. Oh, did that not paste in right? User error, sorry about that. Because I had to disconnect my mouse, so I'm working with the laptop trackpad thing, and it's just so easy to make mistakes with this darn thing. I had some USB ports die on my machine, so that's why I'm just a bit limited until I can get that fixed. All right, let's do one more. Come on, trackpad. Don't mess me up here. All right, so we've got 2 entrants. So let's go back up one last time and switch back to the primary account so we can pick a winner. Let's do pick winner. Cool. All right, now let's run this again with the same lottery ID. This time we want to see the results because the results of our first lottery should have been recorded. Oh no, we're still getting a 0 address, aren't we? So something's gone wrong here. Can you guys spot the bug? Let's see if it looks like we have a winner just by looking here. Yeah, it looks like this account should be the winner. So I guess there's something wrong with either the mapping or the way I'm updating it. Let me see, mapping uint, mapped to payable address, public, lottery history. I think that looks good. Get winner by lottery, uint, which we're calling lottery, okay. That's going to return a payable address. Lottery history of lottery. So that looks good to me. There must be a problem with the way we're updating it. Oh, I see the bug. Can you guys see it? It's right here on line 43 and 44. So this is an order of operations kind of thing. We need to have this above this line because we're setting this to the next lottery's history by mistake. Because we've already incremented the way we had it just a second ago, we've already incremented ID and then we're using it here. See what's happening? So that means we can actually try this on 2 and I bet you it'll give us the winner of our first lottery. Let's see. There we go. All right, so at least we know exactly what's happening. I don't think I'm going to retest this because it's pretty obvious that that was the issue. So we fixed it now. So I think that's all I wanted to do in this video. Yeah, thanks for sticking with me. Hopefully it was interesting. Hopefully you learned something. Now I'm going to do a part 2, a follow-up to this video, and we're going to take another look at how we generate a random number. So remember earlier in this video we discussed that this is just a pseudo-random number using a hash algorithm and the owner and block timestamp because really this is publicly available data. So in theory this random number could be discovered, could be derived given this data. So in that next video we're going to be leveraging something called Chainlink, which is a decentralized blockchain oracle, more on that in the next video, as a way to generate a truly random number for us to use in our lottery contract. So this is going to be a big improvement, I think, to our existing lottery contract. I hope you guys can join me in that next video and continue the journey here. And so anyway, thanks so much for joining. If you guys have any issues or any questions, as always, please feel free to leave comments, and I try to answer those the best I can. But other than that, yeah, hope to see you in the next one, and hope you guys have a great day. All right, take care.